Welcome to Data Analysis with Python. In this video, we're looking at a capstone project on local government budget optimizer. Local government budget optimizer. Now, the data set I'll be using here, of course, like most of the data set I've been using, it's actually made up and just to so we can just use that to understand local government budgets in a way. All right. So the yeah, the data set is this LGA budget data, and it's an Excel document. So there we have, I always recommend seeing the document in its original form before we even take anything to Python. So here we have all these we have these columns. Okay, so we have the LGA name, the health budget in US dollars, the education budget in US dollars, the infrastructure budget in US dollars, the submission date, this and the officer who submits, and the comment attached to that. And obviously, you can say that the data set is unclean, like it has so many things we need to deal with. So it requires some cleaning and pre-processing. And then we have 75 data points, 75 rows, and one, two, three, four, five, six, seven columns. So that's the data set we are using. So of course, um, this in the introduction, this project provides a comprehensive analysis and visualization of local government budget submissions, identifying data inconsistencies, budget allocations, and submission trends across various sectors. Okay, so the first thing we want to do is data loading and pre-processing. Okay, so of course we need Pandas to load the Excel data set, and then we need NumPy to do some numerical stuff. So maybe the first thing I want to do is so just upload the data the way it is, and then we just want to visualize using this DF. Okay, so then it brings out all these things. So we have 75 rows and seven columns, just like we know, 75 data points, 75 LG, maybe not one LG because we have some LGs repeated, based on the different dates we've collected. Okay, so that's the first thing we have. And then, okay, this is what I've run here in case that was not clear enough. And then we can create another cell down there by just we can insert cell below like this. So let's do more of that. Escape below, and then I can put this here. So and then we go ahead and do some cleanup again. So we clean up. So for this cleanup now, for the columns, we are stripping off all the extra any number that has extra space around it. So the second line is going to strip off all of those things. And then for the replace, now we're replacing every unknown with NaN. Okay, we're replacing every unknown with NaN. That's still manageable. Or we could as well just have removed. I mean, we could. What we are used to doing is to drop all the NAs, not available values. But here we are just replacing that with NaN, so we can just get by. So here, this is what I've run to get that. So here you see any column that had some messy stuff is gone. So in this case now, you see all this question mark and everything has now been replaced by NaN all the way, NaN. So we don't have all those question marks again that can give us problem when we are analyzing. So that's one level of cleanup. So let's see another one. We want to convert the uh numeric columns, right? And then we also want to pass the dates. So after doing all that, then we run this again. This is what I have run here now. And then we have all this. Um, so so we have all this now. So that takes care of the cleaning process. Now, okay, I'm deleting all this. Now, the next thing I want to do, okay, we are still talking about data cleaning and deduplication. So in case we have duplicate values, we have missing values and everything. So this is still part of it. So here I want to sort by submission date and keep the latest submission per LGA, right? So here now we have DF latest, DF sort values based on submission dates. All right. Group, then we group by the LGA name, and then we start from the latest one from the last one, and we reset index based on that. And then the next thing you're doing is want to see summary of missing values. Do we have any missing values? Want to see all that. So I just press Control Enter here. Okay, so we see that the LGA name. Okay, maybe I should just remove this first and then just visualize this df underscore latest step by step. Okay, good. So now you can see all the based on the dates of the most recent dates of submission. Now we have 30th of April, 14th of April, and so on and so forth. So from according to the currency of the submission, and then the LGs are now numbered according to they are now listed according to the LGA numbering, right? LGA1, LGA10, and so on and so forth. So we have all this like that. Okay. So I need to create extra cell for that which I copied already. Um, so we can do this and create this extra cell. And I come here and we have um the null values, right? So we have all LGA names are available, so none is missing. Health budget, 8 missing. Education budget, 14 missing. Infrastructure budget, 11 missing. Submission date, 3 missing. Submit the person who submitted, 7 missing. All comments are available, so no missing comments. That's what it simply uh, tells us. Okay, then the next thing we want to do now is want to do, I mean, I think this is the first time we are doing a missing data heat map. So if you are interested, you can do a missing data heat map just to show where you have data missing and all of that. And of course, to do a heat map, right, Matplotlib cannot do heat map. You have to use Seaborn or any other tool like Plotly or something like that. But here we are using Seaborn as you see in line 2. Of course, Seaborn is based on Matplotlib, so we need to anytime you're using Seaborn, you also need to call to import matplotlib. So, and then we plot the figure, we dimension the 10 by 5, then the SNS heat map now. So we are doing the heat map of the DF latest is null. So we are doing for these null values, and we're using variables, and you can always change this. So the color bar is false. Um, so we can change it to true to see what happens after running. Then we have the title, and then it shows us what. So this is what the heat map, the missing values heat map looks like. Okay. What if I say instead of false, now I call this C bar, I say it's true. So it means it shows us a bar, right? Like that. But because we aren't seeing much, just missing values, so that may not be so necessary to use. So then this is very this, right? I always like this color map rainbow. Okay, something. So this is what we have in this situation now. So whatever you want to do. All right. So next we have the budget distribution and sectoral comparison. So we want to compare how the budget is distributed according to sectors and everything. So here we have histograms of budget distributions. So we do talk about the axis and we do some subplots, and we have length based on the budget columns, and then we have the figure size maintained there. Then we have budget distribution across LGAs there. So all these other things just takes care of that. And then apart from that, we also have average sectoral budget bar plots. I guess we just take it one by one so we can appreciate what we have in each case. So okay, let me cut this off now. Okay, I have a bit of issue here. Okay, that's done. Okay, I guess I can click now. Okay, so all right. So I cut this off and create new cells below in case I need more than one. Okay, so now this is what we're doing. So we want to do budget distributions and sectorial comparison. So the first one is about the budget distributions. So if I run that, see what we have here. So we have health budget distribution now. So see how many, so here we can see the number of LGs and their budgets. So for instance, for a budget around this value now, we have two LGAs. That's for budgets between $30,000, I mean between $300,000 and $350,000. We have two LGAs. For budgets around $35,000, you have just one. So the average budget is roughly 500,695. That's what this average thing tells us here. So the average budget is about here. So there's no LGA with 550,000 budgets, but we have LGAs with less and more than that. That's what we have here. And for the education budget, we have the same thing. The average budget for education is $734,000. And then for infrastructure budget, the average is, of course, infrastructure is expensive. So that's like 1 million plus dollars, right? For infrastructure budgets. So we have up to five LGs that have the highest uh, health budget. We have about six LGs that have the highest education budget. We have about more than six LGs that have the highest infrastructure budget. So the other part, if I bring it down, is the average sectoral budget per plot. So across health, education, and infrastructure, we want to see how what the spread looks like. Okay, so we see that generally infrastructure budgets cost more than the others across the local government. So across the local government, and that's why we are talking about average sectoral budget across LGS. So this is the code that led to all of that. Okay, and these are the plots this way. Okay, what if you're interested in budget ratios and efficiency metrics? So maybe some way of seeing how well the budgeting is going. So budget ratios and efficiency metrics. You can compare how much each LGA is investing in one sector relative to others. So that's what we are doing here. So now, of course, we are using pandas and is already important. We don't have to keep doing this, but I mean, we've done it all the same. So here, we want to ensure budget columns is defined. So if budget goes not in globals, then we raise the value error. Budget columns must be defined as a list of budget columns. That's just a way to mitigate against some error, which if you remove it doesn't affect so much. But in some cases, if you want to put things in place that in case something goes wrong, you just get an error message instead of an error outputted itself. So calculate ratios with handling for division by zero and missing values. So if of course if you divide by not available value, it's going to give you some error message. So we take care of all of that here. So you say DF latest health to education ratio. So what is the ratio of health to education? And then where if you have the education budget, because you're dividing by education budget for sure. So where if you have education budget, right? So you don't want to use anywhere there's the education budget is zero. That's what this line 10 is about. And then you now have DF latest budget divided by education budget. So wherever you have education budget not available, then it will skip it and just go straight to give us where you have health budget divided by education budget because we need health to education ratio. So we want to see who is if you have something greater than one in this case, it means that local government spends more money on health than education. If you have exactly one, it means that such local government spend the same on health and education. And if you have less than one, right, it means they spend more on education than health or less on health compared to education, right? Then you also have the total budget, DF latest budget columns and everything. So yeah, you want to do infrastructure to total ratio. That is what percentage of your budget are you spending on infrastructure? All right, that's what this takes care of. And then we can display all of this right here. So you can see that LG1, the first LG, the health to education ratio is 0.6, meaning that they spend more on education than health or less on health compared to education. And then the infrastructure to total ratio is zero because maybe there are some missing values. Then if you look at LGA 11, they spend more on health than education, and infrastructure to total ratio, they spend like 34% or roughly 35% of their budget. They budget more than about 35% on infrastructure, right? So and so on and so forth. That's what all this is about. Now we have all this NAN because we had allowed that in the first place. So if we wanted to remove all the NANs, we wouldn't have seen all this. But there are sometimes we just want to have it this way for the case of if it's necessary for accountability. And then we have officer submission performance. So now maybe you have budget officers in each local government. You want to see which of the officers are really doing a good job and all that. So we can also do an analysis about officer submission performance. So submissions per officer, right? So we have officer count. So you want to count the officers, you just say define DF underscore latest submitted by. So we are grouping the officers because it's under the column submitted by. So we count their values, and anywhere we then we anything that is anyone that is not available, we won't drop it, right? And then we now plot that into some kind of into a bar, all right? And we use coral color to take care of that. We can change the color. So we have number of submissions by officers, and we have the count on the y-axis, and then we have the x sticks rotated 45 degrees. I'll vary that to see what we have here. So Officer D and Officer A seem to have the highest number of submissions by officer. Then we don't have we have some officers that, I mean, no particular officer submits seven, or how do we interpret that? For seven counts, we don't have the names that maybe there's an omission or something like that. Officer B follows. Officer B and that none go together. They have seven submissions. Officer C is the one who submits the list. So in case you have an award for officers at the end of the month, you can follow this. If assuming that all officers are available, and this is just how they do. But you can also use this to say, oh, was there a change of officers? You know, was it like there was an officer A at some point and the person was replaced by another officer? That's why we have this. So you want to investigate all of that for depending on whatever purpose you want to have. So, but according to this now, Officer D seems to be doing Officer B, D, and Officer A. Officer B and D seem to be doing an excellent job. So you see the label on the x-axis, they are 45 degrees. They are 45 degrees, right? So you can comment that out, and then so it's now like 90 degrees. So, or you can explicitly just do 90 degrees instead of 45. So it just aligns horizontally like that. It just aligns the way you see it, I think, like that. Okay, so we can also do timeline of submissions. So here, we want to see how are they submitting, at what point do they submit, and things like that. Maybe the time is really important to us in this situation. So first of all, if you have not done this before, we want to convert to date time, if not already, all right, because date time is the best way, the best date format for analysis. So that's always important when you're working with dates. So DF latest submission dates, to underscore date time is actually a function inside of Pandas that can help you convert a date into date time, which is good for analysis. And then you create a plot that takes care of all of that, like a line plot. So if you run this now, you see that okay, number of submissions. We have one submission uh, for the most part, but then at some point we have people submitting two, looking at following the dates like that, and so on and so forth. If we do 90 degrees like we did before, the dates will align perfectly like that. So it means this submission here is between these two dates, 1st of April 2025 and 5th of April 2025, and all that. So the highest submissions happen around 29th of April 2025, probably because the month is ending or something like that, right? So at the end of the month, there's maybe like a kind of rush to submit or whatever. That's why we have that many submissions. Okay. Um, so towards the end of the month, you can see it's surely busy based on what we have here. Then we can also do some text analysis of comments. So if you look at the original data set, right, we have a column that talks about comments. So no comment, no comment, pending verification, unspecified, education budget flag. Maybe there's something wrong with the budget. It can be flagged. Maybe you think it's too high or it's too low, or you suspect some foul play. Initial review passed, and so on and so forth. So we have all of this. So we can do a kind of analysis of such comments, like some kind of text analysis of comments. So first of all, we want to see frequency of comment types. So we have DF latest comments, and then we count the values, and we don't anything that is not there, we drop NA false. So unspecified, we have 15 unspecified, no comment 8, initial review passed 6, education budget flag 4, pending verification 2. So that's the frequency of those things. Then we can also tag LGS with flagged issues. So if you see that there are four flagged issues there. So you want to see which of the local governments have those flagged issues. So in case you have something to take care of with such local governments. So here now we have to tag LGS with flagged issues. So DF latest flagged, you are creating a new cell, I mean a new column called flagged, and that is based on DF latest comment, and then any string that contains flag, pending or unspecified. So you have case false and not available false, and then the DF latest you want to see the LGA name, the comment, and the flagged column you have just created now. So you see that LGA1 flagged, LGA1 is flagged, LGA10 is flagged, LGA11 is not flagged, LGA12 flagged, not flagged rather. Anywhere you have false, then they are good to go. Anywhere you have true, they are not so good to go. So you can see many of these LGAs have issues, whether unspecified or flagged or pending verification and things like that. So we can also go ahead and do correlation analysis of the budgets. So here you want to drop rows with any missing number. So because for correlation, right, you need all the data points to be available. You can't work with not available values in this situation. So you want to drop rows with any missing budgets. So df underscore core equals df latest budget calls dot drop any. So any budget that is not available will be dropped, and then we can now create a heat map that gives us the available results. So in this case now, you see the redder the better for strong correlation, and the bluer the better for weak correlation. And so we have, well, the correlations are not so strong, but I mean they are close to 0.5. So -1 is the least correlation, and 1 is the least negative correlation. That's -1. Uh, Strongest negative correlation, sorry, is -1. Strongest positive correlation is +1. So here, all this one you see, because it's health against health, it's 1. So you don't care about the middle ones. But then you see, apart from that, you see education budgets and education budgets and infrastructure budgets are the most positively correlated. And then infrastructure budget and health budget are the most negatively correlated. So it means that the higher infrastructure budget, the lower the health budget, whereas the higher the education budget, the higher the infrastructure budget. Well, I mean, one thing you can deduce from this is that probably most of the infrastructure being built in schools and things like that, and less of infrastructure in health centers. Probably that is why we have this. That may be a reason, and it may not be. So if you need to really get to the bottom of that, you need to do more investigation on that. So overall, we have the following insights. First of all, we have the key insight. Many LGS have missing budget data, especially in infrastructure. So probably the budget officers are not doing a great job, or the local governments don't really have competent hands. So that may inform some policy, like maybe you need to recruit budget officers, or if they are budget officers, you need to query them, or you need to have a training and retraining for them and things like that. So Officer B is the most consistent submitter. Is that really true? I don't think so. I think it's Officer D and Officer A. So I need to update that. Officers A and D. Officers Officers A and D are they are the most consistent submitter, while some entries have no associated officer. Okay, so we have some entries. Maybe the officer forgot to write their name or something like that. Maybe unsigned submissions, whatever. So multiple entries per LG. Of course, LG1 exists and must be duplicated based on submission date. Okay, so we are taking care of the duplication already. So anything, um, so if you have more than one LGA, that's like double entry, right? That's repetition. So we have to remove the duplicates. I think took care of that up there. Then infrastructure budgets have the highest variance, possibly indicating uneven development or inconsistent reporting. Okay. Then some LGAs have flag commenting at quality assurance or integrity checks. So these officers are not doing a good job based on some of these things. So the recommendations, we need to enforce stricter submission validation to make sure that we don't have missing budgets. Then we need to add automated alerts for missing or flagged entry. So once you submit, maybe you have some checklist. Once somebody submits and something is missing, they just get, maybe they can't even submit. So they know to not as far as they're not able to submit, they will go and correct whatever the errors may be. Then we can implement a standardized comment structure, e.g., flag error code verification status, so that we can have that consistency. Then we can also consider deploying a dashboard to monitor real-time LGA budget submission. So you can have a dashboard. Maybe one of the projects, maybe one of the capstone project can be about a kind of LGA budget submission. Maybe I'll use this same thing to do a kind of dashboard to know, oh, this LGA has submitted, this one hasn't submitted. Let's see if that's what I end up doing. So that's the end of this local government budget optimizer capstone project. So you want to go through, of course, you have access to the data. You can do more with this for sure. So maybe you're interested in a particular question, you may want to investigate all of that by downloading the data sets and the code sheet also, and you can add your own insights and recommendations based on what you find. So with this, we come to the end of this particular video. Feel free to try your hands on all the data set. Just try to do different things on the data sets available via the link. And of course, let me know if there's a kind of data set you like me to work with, so that you can get the kind of insight you want. If you have subscribed to the channel, of course, you are getting a lot of knowledge on data analysis already. And if you have not, you want to do that right away so that I can always get alerted. And of course, subscribe, hit the notification bell, I mean, so that I can always get alerted each time a new video is released. And be sure to like and share so that more people can have access to this great content I have going on here. Till I come your way again, keep doing data right. Bye.